Today I'll talk about carrier sense multiple access with collision detection, CSMA CD. What is this? Actually, in case of data transmission, uh, it is used for congestion control and collision detection. So when one station sends a packet to any other station, before sending the packet, it senses the medium whether it is free or not free. If it is free, then it sends the packet. Otherwise, it doesn't send the packet. So in this technique, station senses the medium before trying to use it. And actually this CSMA, it works in a principle. What is that principle? Either we can say sense before transmit, that means before transmitting the packet or frame, sense the medium. If it is available, if it is free, if it is ideal, then send the packet or frame. In other way, we can say listen before talk. Now the thing is, CSMA requires that each station first listen to the medium before sending the packet. So in this technique, what happens, each and every station, they need to sense the medium before sending any packet to avoid collision. Now one collision model I would like to show you. Say 4 stations are there: station A, station B, station C and station D. Now station A is sending a packet to station D, and the time point was T1. At that point of time, station A is sending a packet to station D. So first station A will sense the medium, as at that time no other station is sending any packet, therefore the medium is ideal, so A can send the packet to D. Say this way the packet is traveling from A to D. Now the thing is, at point time T1, if B also senses the medium, B will also get that the medium is ideal or free, as it was in case of A. Even any other station like C, if it senses at that point of time the medium, it will get that the medium is ideal. Now if B starts sending a packet, say in this direction it is sending, so there will be a collision here. If C starts sending packets, say in both the directions it is sending, so here will be a collision as well as here will be a collision. So I hope this collision picture is clear to you. Now we'll know what is vulnerable time or propagation time. Here it is said that it is the propagation time or TP. This is the time needed for a signal to propagate from one end of the medium to the other end. What is that? Let's see the diagram once again, it will be clear. So here also we have 4 stations: station A, station B, station C and station D. Now at point T1 time, station A is sending a packet to station D. This way the packet will travel, and after some time at point time TP, the packet will reach to D. Now if I draw a straight line here, this is also T1, Now the gap between T1 and TP means this area. This is called vulnerable time or propagation time. Means the time the frame or the packet will take to reach to its destination. Now you see one thing. If B also starts sending packet at the same time, say in both the directions B is sending, so here is a possibility of collision, here also a possibility of collision. Now when B and C, they will senses the medium, they will senses here. Alright. In congestion control, how can we detect the chances of collisions? Three different persistence methods are there in CSMA for that. First one persistent method. What is that? If the station finds the line is idle, it sends a frame immediately with probability 1. Let's see the diagram of it. Say this is the channel senses. If it is idle, the station will send the signal, but if the channel is not idle, if it is busy, then definitely again it will sense the channel. So this is one persistent method. The next one is non-persistent method. What is that? If the line is idle, station sends the frame immediately like the previous one. If the line is not idle, it waits for a random amount of time and then senses the line again. So what is that? Let's see in the diagram. Say here it is sensing the channel. If the channel is idle, definitely it will send the signal. But if the channel is busy, in that case it will wait for a random time, and after waiting again it will sense the channel. So this is non-persistent method. What about the third one, that is P-persistent method? It combines the advantages of the other two strategies. That means one persistent method and non-persistent method, the best features of these two we implement here. P-persistent method. Let's see the diagram of this P-persistent method. Say the channel is sensing here. If it is idle, then it will compute the probability outcome. If that probability outcome is less than P, then definitely it will send the frame. But say when it is sensing the channel, if it is busy, definitely again it will sense the channel. While compiling this probability outcome, if the probability outcome is greater than P, then it will wait for a certain amount of time, a time slot, it will be waiting for that. After that again it will sense the channel. Still if it is busy, then it will discard the frame. But if it is not busy after waiting a time slot, then definitely it will sense the it will compute the probability outcome of that channel again. So I hope this is clear to you. Okay.